Okay, we're going to discuss the binomial distribution. So in the last video or videos, we were just describing discrete probability distributions in general. But here we're going to talk about something specific, something we call the binomial distribution. And it, in particular, describes probabilities of dichotomous outcomes. Dichotomous outcomes. So what do I mean by that? Just two outcomes. 1, 0, yes, no, heads, tails, anything like that. And it's got a number of characteristics. So first, there are n independent identical trials. That just means that from one trial to the next, they do not affect one another. Each trial has two outcomes. That's the whole dichotomous thing. So we define it generally as just success versus failure. And the probability of a success is constant throughout each trial. And we call that probability of success P, which means the probability of failure, which we call Q, is just 1 minus P. And so then our random variable is X, and it is the number of successes in n trials. And when we calculate probabilities, so what we call the probability mass function, or essentially when we are interested in X is equal to some value, it is equal to n choose X. So that's using combinations like we learned before. The probability of X, P, raised to the number of successes we're interested in, X, times Q, the probability of failure, to the n minus X. Because if there are X successes in n trials, that means there are n minus X failures in n trials. The expected value of X, so the mean of a binomial variable, is equal to NP, just the number of trials, times the probability of success. And the variance of a binomial random variable is NPQ. Okay, so let's do an example. And of course, because we can't get away from coin flips, that's what we're going to start with. So let's start with a coin flip. Let's say we flip a coin 3 times, and X is the number of heads that we are interested in. So here, N is equal to 3, because we have three trials. P, probability of success is 0.5, because it's a fair coin. And then Q, which is equal to 1 minus P, would be 1 minus 0.5, which is also 0.5. And let's say we're interested in the probability. So let's find the probability that we get, probability of 2 heads. In other words, X is equal to 2. Okay, so let's use our formula. So the probability, so using this formula up here, we have the probability that X is equal to 2 is equal to, so N here is 3, choose 2. Probability of success P, which we found to be 0.5. So how many successes do we want? We want 2. And then Q, which is also 0.5 in this case. We would raise this to the n minus x. So the n here is 3 minus 2. So 3 choose 2 is just 3. And then we're left with 0.5 squared times 0.5 to the first. So this becomes 3 times 0.5 cubed, which is 0.375. Now let's find the expected value of this random variable. So the expected value of x is equal to NP. So n here was 3, p was 0.5. And so we would expect 1.5 successes. And then finally, the variance of x would be equal to NPQ, which would be 0, 3 times 0.5 times 0.5. That is equal to 0.75. And of course, if we wanted the standard deviation, it would just be the square root of 0.75. And that is equal to 0.87. Okay, so in the next video, we will do another practice example.